We'll start with a mini activity. What I want you to do is, here's 3 squares that I've made. Draw in the diagonal for each of these squares, and then let's find its length. I'll do the first one for you. So diagonals, a diagonal looks like this, goes from vertex to vertex. Notice that these are by definition squares, so these are all right angles. So if you would, calculate what the length of this diagonal should be for each of those 3 squares. Notice this is a general x. With any luck, you got something resembling the following. 3 squared plus 3 squared equals c squared. So you get c squared equals 18, blah, 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 blah. C should be square root of 18, which simplifies to 3 times the square root of 2. 9 times 2 is 18, 3 roots of 2. Let's do the same game here. We get c squared equals 5 squared plus 5 squared. C squared equals 50. Square root of 50 is 25 times 2, which is 5 roots of 2. Maybe even more general, we use x and x and said c squared equals x squared plus x squared. C squared is equal to 2x squared. If you find the square root of each of these, you get c, and you get the square root of 2 times x squared. You know the square root of one of those 2 things. Which one?
X.
What's the square root of x squared?
X.
So that in general, we get c is equal to x roots of 2. Why did I choose a square? What sort of triangle? What are the degree measures of the angles of this triangle?
90, 45, 40. Because it's in isosceles.
When we draw a diagonal, it bisects the angles of a square. So each of these are 45, 45, and a right angle 90. You also very correctly noticed that these are all isosceles. A 45, 45, 90 triangle is an isosceles triangle, which you should have discovered last term when you looked at compare the angle measures in a triangle and noticed that angle, if you have the same measure inside a triangle, then the opposite sides are the same measure. Which means, in general, since this worked, so it didn't matter what x we chose, this works for any value of x. The 45, 45, 90, the pattern for 45, 45, 90 triangles is that each leg, or how about the hypotenuse, is the square root of 2 times as long as either leg. The hypotenuse is the square root of 2 times as long as any leg that's in a 45, 45, 90 triangle. So if I knew a leg, if I multiply by root 2, then I get the hypotenuse. If I knew a leg, I multiply by root 2, and I get the length of the hypotenuse. Take a leg, multiply by root 2, I get the length of the hypotenuse. So for example, if I had a couple triangles here, these happen to be 45, 45, 90 right triangles. So what's the length of x without doing any Pythagorean theorem work whatsoever? What's the length of x? find a leg, multiply it by root 2. Or just leave it as the exact value, and it's even easier. Just take 4 times root 2, and you're good to go. If I tell you the hypotenuse, what should the measure of this leg be in this 45, 45, 90? What times root 2 is 3 roots of 2? 3 is. If I tell you the hypotenuse, say what times root 2 is 3 roots of 2? 3. So x has got to be 3. And part C, you could do this 2 ways. You could if you wanted. You could use Pythagorean theorem here, because we know x, and 2. So you could say square root of 2, you could say x squared plus x squared is 2 squared, solve for x. We also know that 45, 45, 90 triangles have to be isosceles. Or the converse of that is, if a right triangle is isosceles, then it's a 45, 45, 90. So you could define x. You could just do the old school, x squared plus x squared equals 2 squared. We could also use this new idea. What times root 2 is 2? If I took square root of 2, and what would I need to multiply it by to get 2? Itself. So root 2 times root 2 is 2. Or that means each of these guys better be root 2. What kind of triangle must this be? It's a right triangle. It's also isosceles. Every isosceles right triangle is a 45, 45, 90 right triangle. Since it's a 45, 45, 90, it fits this pattern. That the hypotenuse is root 2 times a length. So what this picture is saying is, what would I need to multiply root 2 by to get the hypotenuse? What times root 2 is this number? What times the square root of 2 gives me 2? Root 2. So therefore, each of these x's needs to be root 2. Because a leg times square root of 2 is the hypotenuse. So square root of 2, so whatever this is, times the square root of 2 should give me this number. Again, if that's not working for you, you could always just fall back on, since I told you those two values, you could fall back on x squared plus x squared equals 2 squared. And say 2x squared equals 4. X squared equals 2. Therefore, x must be the square root of 2. Would be another way to get to the same answer. It's similar to this one. It's similar to this one. And then I said, what times square root of 2 is 3 roots of 2? 3 times square root of 2 is 3 roots of 2. What times itself? What times root 2 is square root of is 2? So you say x times the square root of 2 equals 2. What x makes this true? Yeah, it's one way. It's one way to say what times this is whatever's over here. In this case, it happened to be itself. It happened to be square root of 2. No, if it was like 3. Like, what would this be? Well, you could just divide both sides by root 2. X equals 3 over root 2. Well, this is an improper thing. We should probably simplify this radical. You could mix that up. But the gist of the thing is, if it's not evident, then since these are 45, 45, 90s, that means the legs are the same. So you can do x squared plus x squared equals the hypotenuse would be a second way to solve it. You can always fall back on this guy. You can always fall back here if you need to. Okay. Our second special right triangle is going to be made from an equilateral triangle. So if I take an equilateral triangle, what are the degree measures of an equilateral triangle? What are the degree measures of an equilateral triangle? 60, 60, and 60. I take an altitude and drop an altitude down. We divide this 60, 60, 60 equilateral triangle into two parts. And what's nice is that an altitude of an equilateral triangle is also a perpendicular bisector. So we cut this side into equal parts, and we get a nice right triangle. How long is this piece of our now half of 60 or 30, 60, 90 triangle? How big is this piece compared to the hypotenuse, this side? What kind of triangle was this to begin with? Equilateral. What's equilateral mean? All the sides are the same length. Agreed? So then how should this part of our 30, 60, 90 that we just made compare to this part? We said this side and this side are the same length. So if we cut this side in half, it should be half of the hypotenuse. This side needs to be half of this hypotenuse. Because we cut this side in half, so since all the sides start at the same length, if this is half of this, then this should be half of the entire hypotenuse. Half of the hypotenuse. The side across from the 30-degree angle is half of the side across from the 90-degree angle. We can show the relationship with this. We could prove to you in variables what it should be. I'll do that in just a second. We'll do this we'll do a little mini proof. So this is twice the length of this side. We want to find what this third side is. You use Pythagorean theorem, you get what? Sides leg squared plus leg squared equals hypotenuse squared. We're going to do a quick algebra proof here to show what this length should be in relation to these two. So if I call this altitude here b, I know this is, whatever this is, it's half of this. Or this is twice of this. Agreed? This is twice of whatever this has to be. Because it's just an equilateral triangle. And we have no idea what this is. So we're going to try to figure it out. Maybe, with any luck, it'll be in relation to these two. Well, what's 2x squared? 4x squared. So if I want to get b by itself, how about I subtract an x squared from both sides? What's 4x squared minus 1x squared? 3x squared. So if I want to take the square root of both sides to get b by itself, b is square root of 3x squared. How can I simplify that radical just a little bit? This looks a lot like the one we had before. We had x roots of 2 For a 30, 60, 90 triangle, the side that's across the middle side, or the side that's across from the 60-degree angle, has got to have this relationship, which is the following. For a 30, 60, 90-degree triangle, the following holds. 1. The shortest leg is half the length the shortest leg is half of the length of the hypotenuse. And 2, the longer leg is square root of 3 times the short leg. This is the shorter leg. So then let's find either x or y. Which one sounds more fun than fun?
X.
X. Okay, what should the length of x be?
4.
4, because it's twice as long as the short leg. Okay, then what's y? Y is the longer leg. What's the relationship with the longer leg? It's root 3 times the short leg. So what should, in exact form, the length of y be? Oh, look at that. That was super hard to calculate. Okay. How about B? Here's another 30, 60, 90 triangle. X is the short leg. Y is the hypotenuse. Okay? If I know the longer leg, what's a relationship I know with the longer leg? Root 3 times the short leg. Okay, so then that means I should be able to figure out what x is, because x is a short leg. So what times root 3 is the square root of 3? 1. 1 times root 3 is the square root of 3. Therefore, x is 1. If x is 1, what's the hypotenuse?
Oh, isn't it? Yeah.
If x is 1, then y is twice of that, which is 2. Here are 4 more and we're done. First of all, I want you to do 2 things. First, identify which kind of special right triangle this is. Then once you've done that, find the missing side lengths. So if you know the short leg, how do you find the hypotenuse? Double it. So if you know the short leg, double it, and you get the hypotenuse. So y is 26. Last one. What kind of triangle is this guy?
45.
Oh, the 2 angles measure the same. So x has got to be 45. And if you know the legs, how do you find the hypotenuse? So 45, 45, 90?
It's times square root of 2.
Leg times the square root of 2. So y is 12 roots of 2. Notice I didn't even have to use decimals at any point throughout this. I don't expect to see decimals out of you guys at any point throughout this. And tomorrow when you take a quiz on this stuff, I do not want to see decimal answers for special right triangles. I want to see exact radical answers. I do not want to see approximate decimal answers. I don't want those things. Just use the square roots. Life's good.